Looked at finding solutions to equations and inequalities, and also graphing equations and inequalities. What we want to move on to in this section is finding the solution to systems of equations and systems of inequalities. To start that off, first we want to look at what it means to find or to have a solution to a system of equations. In example 1, we're going to look at the points -7, 5, and 5, 7 to determine which one is a solution to this system of equations. What we need to do is test each pair and see if it makes both statements true. In order for an ordered pair to be a solution, it has to make the first statement and the second statement true. We'll start off by looking at -7, 5, and we'll plug those x and y values into the first equation, giving us y equals 1/5 times -7 plus 6. And what we're asking here is the question, is this a true statement or a false statement? In this case, it's going to be a false statement because this expression on the right-hand side actually comes out to be 4.6. Since -7, 5 doesn't make that first statement true, then no, this is not a solution. Next, we'll look at the point 5, 7. We'll start off by plugging it into the first equation. So is 7 equal to 1/5 times 5 plus 6? Well, 1/5 times 5 is going to be 1 plus 6, which does equal 7. That checks out, so we know that 5, 7 is a xy pair that satisfies the first equation. Now we need to check and see that it also satisfies the second equation. So is 7 equal to -3/5 times 5 plus 10? -3/5 times 5 is going to be -3 plus 10, which will give us 7. So that also checks out. Since our ordered pair 5, 7 is a solution to both equations, meaning it makes both equations true, then yes, we do have a solution to this system of equations. In example 1, we did that process manually. We can also use a calculator or Desmos to take care of these calculations for us. So example 2, we'll switch over to Desmos, and we'll type out this problem using either the asterisk star symbol or parentheses for multiplication. We'll take 10 times -4 minus 8 times -7 and see that that comes out to be 16. So that is a solution. That does make that first equation true. Now we'll test the second equation. We'll take 9 times -4 minus 8 times -7, and we'll see that that gives us 20. Since that xy pair makes the second equation true and the first equation true, then that tells us that yes, this first ordered pair, -4, -7, is a solution to this system. If we went back and tried this with 2, 0, we could start with either equation. We would take 10 times 2 minus 8 times 0 and see that that gives us 20, which is not a solution, or doesn't make that first statement true, because that first equation should be equal to 16. So 2, 0 is not a solution. Because again, what we're looking for is that xy pair to make both equations true. If so, then we found a solution to that system of equations.